Hey guys, this is Caden and I'm going to be talking to you about paramagnetic levitation. This is a really cool topic and it's super fun to watch. But to talk about how to start levitating random objects, first we got to talk about the different kinds of magnets. So there's these three kinds of magnets here that I've outlined. So there's ferromagnets, paramagnetic magnets, and diamagnets. So ferromagnets are kind of the normal ones that we think of usually, so like iron, that just naturally have magnetic abilities. And I guess you could also include electromagnetics here, but within these two, paramagnets and diamagnets, they're very different from our normal view of magnets. Paramagnets are attracted to other magnets, and diamagnets are repelled by other magnets. And this has to do with their atomic structure. It's not like inherent like in iron, but it's with normal objects. So things like even animals have been levitated, or you can buy these globes that levitate in the air with a stand. And that has to do with this diamagnetic repulsion. This is kind of a messy diagram, but I drew this here. So this is a ferromagnet, and a paramagnet, and a diamagnet. And so ferromagnets, the field lines, the force here, they tend to go through the object, and they even move out of the way to go through the object. And in paramagnets, they just kind of go straight through. And in diamagnets, they go out of their way to go around the object. And again, that's because of the atomic structure of the material. So with something like aluminum, if you look at the valence electrons, so electrons have the shells that they float around in, around the atom, around the nucleus. And the outer ones, they have the outer shells we call valence electrons, the electrons that are in those outermost shells. And so aluminum has 3 valence electrons. So there's the S and the P groups, and so it has 2 S's and 1 P. And it's this 1 P that's unpaired that makes it paramagnetic. And it's that causes it to want to be pulled towards other magnets. Regardless of north or south, they just like the magnets. But diamagnets, like H2O, water, actually do the opposite. So because of their filled valence electrons, they don't like magnets. They get pushed away by them. They'd rather die than be brought close to a magnet, if that helps you remember it. And so it's really cool that we're able to do this with random objects. Basically any material we can cause to have these effects by magnets, no matter what the material, although some might be easier than others. And so it follows the same basic principles that you learn about magnets. So they follow Lenz's law, where the electromotive force, this funky E looking thing, equals the negative flux, change in flux, over change in time. And in this, in flux, of course, is the magnetic field times the area of the object you're trying to levitate. And so this is kind of basic magnets, and it's really, really interesting. But in order to have something levitate, you have to account for a few more things. So in this equation, we see that to make something levitate, it's this B times the derivative of B equals, this is permeability times the density of the object times gravity over chi, which is the magnetic susceptibility of the object. And in this case, so the B is the magnetic field, and then the derivative of that, the rate of change, sorry, not derivative, the rate of change of the magnetic field. We have to make that equal to the permeability of free space, which is kind of like how hard it is to move in that space. So like air, how hard it is to push, times the density of the object times gravity over chi, which we said was the magnetic susceptibility. So that depends on the makeup, what kind of atoms are used. And so this diamagnetic principle is used to levitate all sorts of things. So there are even videos you can look up on frogs levitating in a field. It takes a lot, though, to do that. So because of all the water in an organism, you can make animals float. And hypothetically, we could even make humans levitate using magnets, but it takes a lot of power. It takes 16 Tesla about to levitate a frog, which is a lot. But you can see the same principles applied to make these globes, these 3D globes, float in a stand. So it's really, really cool. But I hope that helps. And if this interests you, keep looking up more stuff on it. It's super cool. But thanks so much for watching my video. Bye.